Hey, what's going on out there? Facebook world, Twitter, wherever you at out there. Just want to kind of say thanks to all you out there who've been watching my videos, been checking them out, posting them, sharing them, commenting on them. Helps me get better as an educator, and also it helps you as a person in whatever mathematics class you're in or whatever class you're in. I can do other videos on other subjects too, based on question and demand or whatnot. But definitely thank you guys for checking the videos out and helping out yourself as well as other people. So today, what I want to kind of get into is talking about E and natural log derivatives. These particular two examples I'm going to go through are not really difficult, but if you don't know your rules, it can be a little bit difficult. This kind of goes back to Algebra 2. Algebra 2 and pre-calculus, where you learn about natural log properties and things like that, on how to deal with multiplying. When you multiply, you add. When you divide, you subtract, things like that. So I'm going to go through two problems and see if we can get it done. Alright? Alright. So the problem that I have here is actually y equals, and I'll put here E and natural log derivatives. E and natural log derivatives. Now that marker is kind of bad, kind of light or whatnot. But let me write the problem down. So the problem is y equals 2x plus 1 in parentheses times 4x squared times radical of x minus 9. Now, the first thing we're going to do, and I'll go ahead and zoom in a little bit so you can see what I'm doing here with the problem. First thing we're going to do is take the natural log of not one, but of both sides. Alright? So, I'm going to set it up like this. Natural log right here of y equals the natural log of 2x plus 1. And since I'm multiplying my logs, my natural logs, I actually add them. So plus natural log of 4x squared plus the natural log of radical, or actually x minus 9 to the 1/2. Now, I'm going to rewrite this again because I have a natural log of 4x squared. If you see here, natural log of 2x plus 1 plus natural log of 4x squared. This question right here actually breaks down into natural log of 4 plus the natural log of x squared. This right here, the 1/2, actually pulls in front of the natural log. And I'll go ahead and explain to you how we do that here right now. Alright? So, next step is to take the natural log of y equals natural log of 2x plus 1 plus natural log of 4 plus natural log of x squared plus 1/2 natural log of actually x minus 9. Now this part here then breaks into, that one comes in front of the natural log. So this is going to turn into, again, natural log of 2x plus 1 plus natural log of 4 plus 2 natural log of x plus 1/2 natural log of x minus 9. That's the next step. Alright, at this point here, I then have to actually derivatize my problem. So, my answer is going to turn into, and I'm going to tell you how to do the U substitution on this particular problem right now. I break out this marker real quick. So, in U substitution, U in this case is going to be 2x plus 1. Okay? U equals 2x plus 1. Now, the derivative of U is actually du equals 2 dx based on the power rule. Alright, so now the next step is going to be take the derivative. So the derivative of natural log of u, which is what this is basically now, is actually 1 over u du. So this derivative actually turns into 1 over, or actually 2 over 2x plus 1, because 1 over u is 1 over 2x plus 1. du is actually 2 right here. So as you see the breakdown, it goes 1 over 2x plus 1 times 2. Here's the natural log of u. Breaks down to 1 over u du. So u is 2x plus 1. I put 1 over u here, which is 2x plus 1, times 2. And this turns into 2 over 2x plus 1. So, I'm going to erase that part real quick. And I'm going to continue my derivative here with that u substitution. So, my result is going to be then equals, I'll put natural log of y here. And I'll put the natural log of y, the derivative of natural log of y is actually dy over y, because natural log of y is really 1 over u, which in this case is going to be 1 over y dy. Okay? So I have 2 over 2x plus 1 plus the derivative of natural log of 4. The natural log of 4 is actually a number. The derivative of a number or a constant is what? 0. So we do not include it in the derivative. Alright, it cancels out like that. We do have 2 natural log of x, but the derivative of natural log of x is actually 1 over x. So 2 times 1 over x is actually going to be 2 over x. Plus 1 over 2 times 1 over x minus 9, because the natural log of the derivative of the natural log of x minus 9 is 1 over x minus 9. So 1 over 2 times x minus 9. But then you might ask, well, Jay, I have a dy over y right here. Okay? That's all good, no big deal. In order for me to figure out what dy is, since I had to figure out what natural log of y is and get the derivative of it, I cross multiply. Alright? You use the algebra skills right here to do the problem correctly. Alright? So now, here's what we do. We cross multiply this. So y times all of that is going to be my cross multiplication to figure out what dy is. So I'm going to go ahead and circle this like this. And that's what I multiply. So dy equals y times all of this. 2 over 2x plus 1 plus 2 over x plus 1 over 2 times x minus 9. Okay? Now, there's a small little trick to this problem. Small little trick to this problem. How many of y'all think you can get that? Or get this problem? I'm going to give you a second to think about that as we go. A little trick to this. And the question I ask you or challenge you is to think about what y equals. Now that I got dy right here and I want to solve for dy, I got to figure out what y equals. So technically, you out there thinking probably guessed it. Okay? As you sitting there writing down on your paper, you probably understand that y, on this side actually, y actually equals the y up here. Okay? So y equals 2x plus 1 times 4x squared times radical of x minus 9. I'm going to draw a little arrow here to make you see that. Alright, then I'm going to finish off. So I'm going to substitute y back into the equation. So the derivative of this whole thing in natural log terms is 2x plus 1 times 4x squared times radical x minus 9, then times all of this, times, I'm going to drop this down actually here, times 2 over 2x plus 1 plus 2 over x plus 1 over 2 times x minus 9. And I'm done with my problem. This is my final answer. All up in here. These two here. Final answer is 2x plus 1 times 4x squared times radical of x minus 9 times, in big old block parentheses, or what I call block, 2 over 2x plus 1 plus 2 over x plus 1 over 2 times x minus 9. And that's how you complete an e/natural log derivative to completion. Alright? If you have any questions on this problem, let me know. Hit me up on Facebook. Alright, under J Complicated Veal. You can also hit me up under Twitter, under Complicated Newt with a K. You can also hit me on my business page up on Facebook, It's Not Complicated Tutoring, or email me, it's not complicated at texastx.rr.com. Alright, I'm going to do another video of one more of these, and that's going to be it for the E and natural log examples. I'll do more later, but right now I'm just kind of giving you some little snippets about how it works. Alright, if you have any questions, let me know. Other than that, thanks for watching the video. Please comment. Please share. Holla.